Let's see if we can find the intersection of these two sets. We've got this set here, 1, 2, 4, 6, and this set 0, 2, 6, 8. And the intersection, this is the set that contains the elements that are common to both sets. So what's common here? Well, let's just go through them. There's a 1 here, but no 1 over here. So 1 does not belong. There's a 2 here and a 2 here, so a 2 does belong. Anything else? There's a 4 here. There's no 4 over here, so 4 does not belong. Over here there's a 6. There's a 6 here, so 6 belongs because it's common to both. And anything else? Well, that's all that's in this set. Now this set has an 8, but there's no 8 here, so we have the intersection. So now we have these two graphs, and what we want to do is specify the intersection, or actually graph the intersection. Now the intersection we know is a collection of common elements. Now look at this top graph and the bottom graph. You can see if you just line them up what's common here. Now this open parentheses is the book's way of saying we've got an open circle there. That means that 3 is not included in the set. And down here we've got a -6, which means a -6 is not included. So I'm going to write the intersection going from here up to here. This is -6, this is 3, and that's going to be our intersection. I'll just indicate it like this. I can't draw that big fat bar. There's our intersection. So in set notation it would look like this. Well, actually in interval notation it would look like this. Open around -6, open around 3. How about if we start number 3 by drawing a graph? I'll draw the number line here. Label it x since our variable is x. And it looks like what we have are all numbers that are strictly less than 2, so we're off to the left of 2, but then all numbers that are strictly greater than -3. So let's at least mark down -3 and 2, and because there's no equal sign here, we'll draw open circles. So how about -3 here, 2 here, because -3, of course, is to the left of 2. And now what I want is this. We're looking for all the numbers that are less than 2. Now the numbers that are less than 2, they're going to be here, right? I'll just do it up here so you can see them. Those are the numbers that are to the left of 2. And then here we want the numbers that are to the right of -3. Now to the right of -3, here's -3, and to the right, those are the numbers that are to the right of -3. And what we want here is this. Give the solution set in both interval and graph form for these inequalities, and this is an and. So I'm looking for the numbers that are to the left of 2 and at the same time to the right of 3. I think I've got them right in here. So if I just bring that straight down, there's the graph. And now from the graph, we can get the interval form, and the interval form just looks like this. Lower limit, comma, upper limit. And because I have open circles, I use parentheses. There we have it. Now number 4 is interesting because look at what we have. We're looking for the numbers that are to the left of 4 and to the right of 7. And so we need numbers that are both of them have to be to the left of 4 and to the right of 7. Now if I draw a picture, okay, here's x. Now I'll write my numbers. I'm going to put closed circles here because of the, right, look at the closed circles. We have less than or equal to, the equals included. So I'm going to put closed circles there. 1 at 4, 1 at 7. Now, look at this first one. The first one says I want numbers that are to the left of 4. Well, the numbers that are to the left of 4, those are over here. This one says I want the numbers to the right of 7. Those are over here. But now I have to look for this. I want numbers that are in both places. Well, there is no number that is both to the left of 4 and to the right of 7. So we're going to claim now that the solution here is empty.